Math problems can be visualized using bar models to represent data that we know and we don't know. A bar model is a way of using rectangles to represent numbers and operations on math problems, particularly when solving equations. In this video, we will be solving equations using bar models. Let's say we have an equation 5 plus 3 equals 8. To represent this in a bar model, we can use rectangles to each term in this equation. We can use a rectangle to represent 5. So let's draw a rectangle and represent this as 5. And another rectangle to represent 3. So another rectangle that represents 3. Since in the equation, we are adding 5 and 3, then it means that we have to combine these two rectangles by simply joining them together. We also have to take note that the terms 5 and 3 do not have the same value. Therefore, the lengths of each rectangle are different from one another. Also, in the given equation, combining this will result in a sum equal to 8. This means that 8 is represented by another rectangle whose length is the same as the combination of lengths of these two rectangles represented by 5 and 3. We can draw this rectangle below the bar representation of 5 and 3. So we put it below. And this particular rectangle will be represented by the sum, which is 8 in this equation. Therefore, this is already the bar model representation of the equation 5 plus 3 equals 8. This certain type of bar model is called the part-part-whole bar model. So what can we say about this particular bar model? So this bar model is composed of two or more parts added together. So you have two rectangles, you add a certain part and another part, but also you have to take note of the lengths of each rectangle. Well, you have to ask yourself, are the two parts have the same value or not? If they don't have the same value, meaning I will use different lengths of rectangles, or if I'm not sure of it, then two different rectangles it is. But if they are the same, for example, they are 2x. So if we're going to represent x and x, both x must be identical to each other. So you have to take note of it. And then, after this, do not forget that the sum is represented by another rectangle. But that rectangle would be below these parts. Okay? And we can represent this one as the sum of these parts, or simply, we can also represent this as the whole. Okay? It will represent the whole of the given bar model. Now, what different equations can we derive from this bar model? We can say that if a whole is simply equal to the sum of each parts, so that's a part plus another part, then what can we say? We can say that if we're looking for a certain part, then that will just be the difference of the whole to the other part. So that's whole minus the other part. Now, let us have a particular example. So let us have an example. X plus 4 equals 9. So how are we going to represent this particular equation in bar model? So let's draw. We have x and 4. So we will represent this as each rectangle. The rectangles must be different with each other because we are unsure of the value of x. So we draw two rectangles, two different rectangles. So this is for x and the other one is for 4. Now, what do we know about this equation? The sum of these two terms, x and 4, is equal to 9. So we draw a bigger rectangle below it, and this particular rectangle is represented by 9. So the whole rectangle is equal to 9. Now, look at this one. If I'm going to copy this particular rectangle, so meaning this part of this whole is 4, and this one is x. So how will I get this one, this value, this part here, if the whole thing is equal to 9 and this part here is equal to 4? We could get the value of x as 9 minus 4. So we'll just subtract. So therefore, x is equal to 5.